So actually, they titled this "More Radical Functions." That's what they call this. All right. So like I said, I looked through this and I thought, well, I really don't know what is a whole lot different. They do talk about. I don't know even what I picked here. This is worth talking about for a few minutes anyway. They talk about a power function, okay? So remember, functions were those, we talked about that I think in the very, very beginning, you know, how they domain arrange and how they have input, output, that kind of thing, okay? So there's lots of different functions. Polynomial functions when you did your Desmos activity, absolute value functions. A power function is going to look something like, well, I probably should write, I'm just going to write it like this. Okay, where this is usually some sort of a number, you know, or it could be a real number, but I'm just going to say I'll put a real number, I guess. It can be a real number, but it's most likely could be a fraction, could be a regular old integer, okay? N is also a real number. So some examples of power functions would be like this. That's the simplest one, kinda. Y equals x squared, which just gives us this little parabola looking thing when we graph it. I'm trying to write here. There we go. So there's a 2. We can put 3, 4, 5, whatever you want there. If we put a negative 2, okay, then that becomes y equals 1 over x squared, like that, which you might recall is actually a rational. I don't think we've graphed anything like this, but this has a asymptote at 0, but it's always positive. So it sort of looks like that as a graph. Okay, then we can have y equals x, and we can have a fraction, which we know is the same as a square root. So its graph looks something like this. Okay, but the main thing is all those are power functions. So anytime we have a y equals x to some power, it's called a power function. All right, so he mentions that here. It's just worth mentioning, I guess, that those are power functions. There's a whole topic that we could spend some time on, but it's not in your book, so there's no reason to spend a lot of time on it. But it just goes through all the different families of functions, they call it. Okay, so power functions and has a family, right? And trig functions have a family, and logarithm and exponentials, all of them, linears, all have a family. So let's see. They have, I'll just look at some of the questions that they have off your assignment, and we can do some problems like those. Here, they just have you do some evaluating, okay? And just to make sure, so when we see the word evaluate or calculate, all right, that means that you can want to probably use your calculator if you need to, all right? So there's a difference between evaluate and simplify. So simplify means I probably wouldn't use my calculator to get a final answer like a decimal. Evaluate or calculate does mean I'm going to do that. So when you see that, make sure that you say, oh, evaluate, calculate, calculator, simplify, probably not so much. So here, some of our favorites here, we'll put a fourth root down because this is what he really likes them in this one. Okay, and they say, well, x equals something like that. Okay, so let's see. We would go ahead and plug these in. There was a question like this kind of on the quiz, right? So we're going to put -2 in here. And of course the 4th root of 1 is just going to be 1. So see, I wouldn't need a calculator on that because I know the 4th root of 1 is just 1. On the next one, I'd rather write it like this myself, but they don't do it that way too much. Okay, so then, since see, if this was simplifying, I would check to see if I had any 4th roots. 1 to 14, of course there isn't any. But calculator evaluate, I'd use my calculator to do that. Let's see. I'm just going to do this. I'd probably do Desmos, but then I'd have to log in. Take me a while. So here, now that I know this, though, I could do this to the 1/4 power. So I could actually go 14 and then do this x to the y, parentheses, 1 divided by 4. Yeah, there it is. 1.934, about. Something like that. Okay. And you probably have a root thing on there, I think. Like I said, I'd probably use Desmos, but I'd have to log in. Let's see. I think it's probably, there it is right there. It's that y to the, most people have a little root with a y or an x right in there somewhere. And you can get the roots of anything you want. Okay. So there's some problems like that where you're just substituting the things in and working on them. Then they have some of the same thing, more evaluate. Like this, and then they say x would be like a -12 and x would be a 20, and it says do it if you can. All right, so let's do this. So again, I just put that in there and use your calculator, use Desmos to figure it out. It says round to nearest hundredth. So I'm going to go 12 negative, to the parentheses. I got to put parentheses or else it doesn't divide it out, right? 7.3. How come it's not? 7.3. Something like, oh, maybe that's. First of all, it should be negative because it's a negative number. Now I'm not trusting this. Did anybody else try it in their calculator or Desmos? -12 to the 4/5. Because I don't think that's, that should have been negative.
Yeah,
Negatives 7.3? Okay, that makes sense. Oh, I guess they wanted me to go to hundreds. Well, 7.3 is what it is anyway. Okay, so then I would do 20. I wonder why I didn't put the negative there. To the 4/5. And I'd do the same thing. You just have to make sure you put parentheses around that power. 10.9 hundredths, 10.99. Again, this isn't, I mean, you're just using your calculator, right? There isn't a whole lot that's that difficult to this. So when wouldn't it work? Well, let's say we have f of x. Let's go to 5/4 this time, so we'll just kind of flip it. And we'll let x equal, do the same numbers. Why not? So when I try this, let's see if this works in here. I think I know what might be the problem. Invalid input. So how come this one doesn't work, right? But this one did work.
We want to put a negative underneath, technically a negative under a root sign.
Yeah, what root is it?
4.
4. So it's an even root, right? So it won't let you do that. Where's that one's odd? Okay.
That's where the I thing comes in, right?
That's where the I thing comes in. And this one's just doing the calculator again. So, okay. So this one, no answer, no real answer, I guess you could say. You probably don't want to say invalid input. Okay. But for this one, I'm not sure what that turns out to be. We can just do it, I guess. Oops. $42.29. So again, all we're doing there is just using our calculators to punch the numbers in and get answers. So it's just not anything that different than what we've done. I'm just looking at some of the problems. Here's some more. They have your graphs and power functions. And the question here is, which function is greater when x is greater than 1? Which function is greater when x is greater than 1? Okay, got to graph them. Well, here we go. Yeah, I see that. By the time I get connected, you guys will already have it figured out. Maybe I'll just do it this way and then we don't waste time here. Ah, poop. Okay. Let me get this all set up here so you can see it better. Now, let's see, I want this off, solving. Come on, get off. Oh, I remember. I have to do this. There we go. All right, back to what we were doing. So let's see. It was y. Get rid of that. Y equal to x to the 1/5. So it's so much easier to use this. 1 divided by 5. Okay, versus y equals x to the 1/2. Okay, and it wanted to know which function is greater when x is greater than 1. Well, let's see. Here's 1. Okay. Oh, here's 1 right there. And which function is greater? Well, that looks like the blue one is because it's up higher. Okay, and the blue one is x to the 1/2. So that's what I would write down. All right, x to the 1/2. So there's questions like this. I mean, I looked through this and I thought, oh, if there's anything here. What other ones do you have to do in this section? And this would be the first one you do, so I guess if you have questions, you're going to ask me. There's some interpreting graphs, but I really don't think you're going to have any troubles with that. So I feel pretty comfortable. Do you see anything on those pages on 380 that you're not, that looks like something you wouldn't know how to do? Okay. All right, so let's look at some, no, I can't connect to it. Okay. All right, so let's look at some solving then. We can do a few of those, and then I'll get you a little break here. The solving ones are the tricky ones, so, of all the stuff we do today. Solving. There we go. Okay, solving some radical equations. So let's start out with some easier ones and then progress. So any equation has a radical in it. So again, we're going to start out with something easy and then progress. All right, that's a really easy one. Okay, so basically we have a radical here, right? We want to get rid of it, so we're going to undo it by squaring. But of course, whatever we do to one side equation, we got to do to the other. All right, so x is going to be 9. Okay, nothing too earth-shattering there. So let's say we have something like this. Now we put a number out in front. We want to try to isolate the radical before we do any squaring, because if we square right now, it's going to be just a little bit more complicated. So let's get just like you would with a normal equation, trying to get x by itself, we're going to do the same thing with this, but we're going to isolate that radical and get it so it's by itself, and then we'll square it. right? So here we have this one. Again, we want to get it by itself. So see, we're going to keep progressing a little bit, making them just a little bit harder. And then divide by 2. We've already done one like this, so when we square it, but the idea is we're trying to isolate that radical and get it by itself. Okay? But it's the whole concept of solving the equation is still the same thing. If that was an x, you just do the same thing, right? It doesn't make any difference. You're just solving it out. Let's try one like this. Let's put a minus. Well, no, we better not. Okay, we'll go 3 square root x minus 4 equals all right. So now, again, getting a little bit more complicated. We got more stuff going on. Still, we're trying to get the radical by itself. All right, so we're just going to continue to do the same conceptual things you did when solving equations before. Now here, okay, I can't do anything with this 4 because it's inside this radical, right? So I'm going to have to leave it until the end. I just added 4 here. And there it is. So as far as a straightforward, I mean, that's pretty complicated. I mean, it's got a couple different steps we had to go through. You know, get rid of the 5, get rid of the 3, square, and then deal with that x minus 4. All right, so, and these are all turning out pretty nice too. I'm surprised I haven't gotten some nasty one yet. That's coming, I'm sure. Okay, so let's try something like this. Again, we're going to move this over here. And you say, well, what's the difference in this one? Well, when you square here, you get 4 minus x, where everything else has been pretty positive, right? So x has to be a negative 21. And that's okay to have a negative answer because when it goes into this equation, right, this minus and this minus cancel, make it positive. So it's all okay.
Is that something that we'll probably have to be checking?
Yeah, actually, when we do the next part of these,
Yeah.
we'll have to go back and check.
Make sure it's actually a
Yep.
valid answer.
Yep, you're right. Okay, so far it's not a whole lot different than what we usually do with solving equations. Okay, so let's try one like this. All right, so now this is similar to having x's on both sides of an equation, right? So a little bit different. Let's see what happens here. Well, I can't do anything with this because I have nothing out front. I'm ready to go. I mean, I have to square it, right? this is going to turn out. Okay. We'll run with this. It's not going to be very nice, but we'll run with it. Alright, this is going to be 2x plus 1. That's good. But this is 3x plus 4 squared, so we actually have to FOIL that out. So 9x squared, 12, so that's 24, so that's 16. Okay, then 9x squared plus 22x minus 15. All right, so now normally the ones in the book are probably going to factor and you're going to get answers, okay? But this one I don't think is going to factor because I just kind of made it up. Let's see. I don't know if I want a guess method. We could try. I think I'm going to try an AC method on this one. 9 times 15. 225 minus. So let's see. 225. I know I'm going to have obviously 3 is going to go in there.
That's not minus.
You are absolutely correct. That's 2 you've caught me now. So only 2 you've got me on today. 75. I just don't think this is going to factor. 5 has to go in there. 45 times, I think.
What's 4x that not?
9's going to go in there 15 times, obviously. Man, if I'd only had that be 24, I could begin with. All right.
9 times 15 is 135. Not
So this is not 225? Did I screw it up?
when that 9 times 15, right?
Yeah.
Yeah, I'm getting.
Yeah. You're right. My arithmetic's off there. I don't even know why I attempted this problem. 135? So that's 9 and 15, right?
Yeah.
3 has to go in there. How about that? 3 goes in there. 45? Okay. 5 has to go in there. 17? 27. So, see, if you had left it as a minus, it would have worked. Alright, but we still solve this. We're just not going to be able to factor it, because I can see it's not going to factor. So, we'll go to Desmos and graph it, okay? And we'll get an answer that way. And I'm going to connect to it after this problem here. Get rid of this guy, get rid of this guy. Y equals 9 x squared plus 22x plus 15. Uh-oh, doesn't have an answer. It's too far up. We're looking for x-intercepts, don't have an answer. So, there's a perfect example of one that doesn't have an answer. Ideally, like I said, what would happen is that this would factor. In fact, it wouldn't take much. We just have to figure out a way to. I could work backwards and make that a negative, and then we'd be all good and ready to go. All right. Let me do one in a book here. It'd be a little bit better for you. Okay, let's try this one. So again, same idea. We're going to square it, both sides. The ones you're going to get are all going to factor out pretty nicely. Okay, so we square, get rid of the radical, square both sides. I wrote it twice, foiled, got that. It's a square, so I have to set it equal to 0 to get an answer. All right, so we'll shove that 3 over, shove the 3x over. And now I'm going to factor it. This one I think I can guess what, messing through it pretty well. Try that out first. So let's see, I get 8 and 1. Oh, cool, if I subtract them, it's going to work. Okay, so I need a negative, so I'm going to put a minus there, put a plus here, see if that, double check that, make sure that works. 1x, 8x, yep. Okay, so then I get x equals 2, and I get x equals a negative 1/4. Are we good so far with that? See what we did? Okay, so now, we should check and see if those answers work, because it's possible when you square things, you introduce a solution that could not be, that might not work. All right, that's called, did they call it in here? Yes, they call that an extraneous solution. So this is E-X-T-R-A-N-E, let me write a little better for you, N-E-O-S. Okay. So they call it extraneous. I don't know why they just don't dump that off and call it extra solution. Makes sense? But, you know, somebody said, we'll call it an extraneous solution. Oh, okay. So the math guy said, okay. Instead of just calling it an extra solution. Because that's what it is. It's just an extra one that you're picking up. So let's go and check and see. I'm going to go back up to the original square root I had, 3x plus 3, and make sure that these two answers are okay. So 2 obviously is going to be all right, because 3 times 2 is 6, plus 3 is 9. That should work out. So if I put x equals 2 here, I get square root of 9, which is 3. I'm feeling pretty good about that. Let's double check the second. Oops, double check. This other side here, let's see, that was 2x minus 1. Okay, x equals 3. I put 3 in there, 2 times 3. Is that what it was? Yeah.
X is 2.
What am I doing?
X is 2, not 3.
I might as well just go home. There we go. There we go. Both sides check. Right? Okay. So that works good. All right. Let's try out the negative 1/4 this time. So I'm going to go here. Okay. Negative 1/4. I'm a little suspicious when I get a negative. Okay. I'm thinking, I don't know if this is going to work. Look at that. I'm going to get a crazy number underneath here. Square root of negative of 2.75. Boy, I don't know. Let's see what I get on the other side. So that's going to be negative 1/2, negative 1.5. But see, this is going to be a negative number, right? And we cannot get a negative number out of that, so that 1/4 is no good. So 3 is my answer. The negative 1/4 is not good. So checking your answers is just darn near as much work as doing the problem. All right? And we sold one that I made up that had no solution, right? And now we had this one which has only one. If we go back to the very beginning here, okay? And that happens when we have an x on this side, all right? And you square this and you square this, then potentially you're setting yourself up for a solution that does not work, right? And all the other times we were okay, but as soon as we introduced an x on the other side, gave us a problem. All right, we'll do a couple more of those after your little break here. I want to see if I can connect to the internet on this thing so we can pop back and forth to Desmos. So take yourself a 10-minute break and we'll do some more of those. Back and going. Think screen's off. All right. I even got hooked up. Okay. Let's do a couple more. And now that I have Desmos, I can show you a little bit more with that. So let's try another one like this. All right, so we're going to square both sides. All right, this we're going to have to FOIL. See, we're going to add an x, subtract a 4. Oh, look at that. Those 4s are just going to go. This is 0, 0. Okay, here, when we factor, right, we're just going to take an x out. We left with x, 0, and 3. So now, all right, that worked out pretty nice. Let's see if we want to check both these answers. Okay, so we could just simply put them in there, right, and see if we get the same answer. So this is obviously going to be 2, but this is going to be negative 2, so the 0 is not a solution. Okay, so then I would check the 3. And that one works. All right. Now, so that's, like I said, sometimes, okay, if you look at this problem, it took almost as much work to check it as it did to actually come up with an answer. All right. So if you want to, you could, if we went into here, all right, and you might say, well, why can't I just do the whole problem this way? Well, because you kind of need to know how to do it by hand also. Let's see, which one was I here? There it is. 4 minus x. I'm going to put that there. Then come down here and go y equals x minus 2. Okay, so here's the two equations. And you can see that they cross only once. So that means that there can only be one solution. And it has to be the one that we got. Let's see what it is. It says 3. Alright, so there can only be one solution. And sometimes, you know, what that was the good thing. That's a lot quicker check than going through and substituting them in. Agreed?
Mm-hmm.
Yeah. Alright, a lot quicker check. So you can do it however you want. If you want to, I would definitely work this out by hand. Okay? Don't go to Desmos right away. Work them out by hand. When you get down to way, okay, I have a solution now, I should check. You can certainly do it by hand if you want to. Or you could just go and graph both of them and say, hey, I'm only getting one answer here, and here's what it is. All right, so that's just using your tools there. But the only time you need to worry about that is when your x is on this side. Okay. If there's a number on this side, like those other easier ones we were doing, there's no reason to check anything. The only time you introduce an extra solution is when you have an x. All right. Is there any questions on that part? We'll do some more, another one, but. Okay. Let me show you one like this. This one, oops, this is the hardest ones we would do. Okay, so now we have something like this, okay, where we have a radical on both sides of the equation. So, what do we do there? And we can't combine them. There's nothing we can do with them. So we just have to square them right from the top. Well, this one's not so bad because I can just square that, get rid of the square root. But here, I have to FOIL it. Yeah, it's a square root of 2x minus 1, right? So I'm going to FOIL that. So we'll FOIL this. I want to step through this one a little slower. So when I take square root of square root, that's going to go away. So it's just going to be 2x. All right. Then I'm going to get a minus square root of 2x there, and another minus square root of 2x there, and then a plus 1. All right. So we're FOILing that, right? So here, multiplying these two things, that square root just goes away. Minus 1 square root of 2, minus another square root of 2, and then plus 1. So that's that. So then we have 2x minus 2 of those plus 1. Well, the 1's here can go. Okay, so that one and that one can go away. So I have this now. Whoops. What? Wait a minute. X minus this equals x. Okay. So now, let's move everything to the other side and isolate this thing here. So I'm stepping through this a little slower. Okay, so after all that work, here's where I am. And I'm still not done. Right? It's craziness. Square both sides. So I have something that looks like this. Kind of a mess. I didn't even make this up. Okay. Let's take an x out. So one answer is, this is 0. One answer is 0. The other answer would be x over 4 minus 2 is equal to 0. X over 4 is equal to 2. So x is going to turn out to be 8. So here's my two possible answers, right? And I know one of them's not going to work, most likely. So I could go back to the very beginning, plug those in, and see which one isn't going to work. Or I could graph the very beginning and see which solution isn't going to work. Since I've already put in all this time, I think I'm just going to graph them and see what happens. Alright, so I'm going to go back to this and type these in. And I'll go back to that note thing in case you're scrambling at this point. Equals, let's see, we got a square root of 2x. Now I have to be careful because I don't want the minus 1 to be underneath that radical, so I'm going to push my little arrow. Make sure I don't have that. Y equals square root x plus 1. Right, and sure enough, there's my one solution right there at 8. Okay? Which is what I would have predicted when I did this. Alright? So, I did all that work, right, and came up with one solution that works and one that doesn't. So, when there's a radical on both sides, it just gets a little bit more complicated, quite a bit more work. Alright, so here we square both sides, get rid of one of the radicals. We got to get rid of one of them. Okay, FOIL, simplify, move things over. Finally, I get it down to the square root of 2x equals something over on this side, and then square both sides, and there we go. Alright, and then I'm going to get an extra solution. Okay. The good news is you don't have a whole bunch of those. Alright, because that would take you probably, if we had, you'd be doing a lot of those long ones. Alright. So we started out with very simpler ones, got quite a bit more complicated here towards the end. I'm just checking to see how many there are with the radicals, and there's very few of those. I think you'll be okay there. Alright, here's one we haven't tried yet. Let's try one that is a cube, alright, because we don't have any of those. Well, at least we haven't done one of those yet. Let's try one of these. Let's see how this changes things. They put a Z here, so what the heck. Okay, so we have that. Alright, so this is a cube root, but it doesn't change anything. You're still going to do the same idea, right? Isolate the radical. It's already isolated. So I don't want to square it though this time. What are we going to do to both sides here? Cube, right? Okay. Notice I don't have a variable over there, so I'm probably not going to get any extra solutions in this case. I don't know why I put an X there. So used to it. And there it is. After doing those ones where we have to square both sides and check and stuff, that seems pretty easy. All right. The only differences that we did is we just cubed both sides instead of squaring. Now, if we did have a cube on the other side and you did have to check, most likely a cube root might be okay, because the reason why we were getting extra solutions on the other ones is because it was introducing negatives, whereas cube roots of negatives, that's okay. All right, so we probably wouldn't have any extra solutions, although it is possible. And if it's a fourth root, do the same thing. Okay? But since this is a cube root, we just cube both sides and work it out. Whew. Questions? Do you want me to do any more on radical solving these? Anything you want to see another one of? Or
When working with fourth roots, it would be the same thing as square roots, right? Where you have to check because you're introducing negatives. That's not okay.
yeah, you'd have to check on in the even ones at all. Yeah. Okay, 2 out of 3. Let's do the last thing in chapter 5. So there will be a number of you that are already familiar with this, so it's going to make your life a lot easier, right? Complex numbers. So, here's the deal with that. An imaginary number which is symbolized by the letter I is equal to the square root of a -1. So, what this allows us to do is now deal with any square root that has a negative. So up until this point, this is what I usually tell the math955 folks, we've had all real numbers. And every time you get a square root of a negative, oh, can't do that, that doesn't exist. All right? But realistically, it does exist. So if we take all the real numbers, all right, and then I merge them with all, here, let's use a better terminology here. Union them with, okay, all the imaginary numbers. So we're putting them all together in a great big pot like you're making stew or chili, whatever it is, right? Got all your ingredients in there. Okay, so you got all the real numbers, all the imaginary numbers. This is called the complex number system. So a complex number will take on the form a plus bi, where a and b are some sort of a real number. So we're taking all the real numbers that you've dealt with, your whole life. 1, 2, 3, -5, 0.6, 2/3, square root of 7, whatever it is. Put them all together with all the i's, square roots of negatives, and then we get this whole big number system called the complex number system, which will look like this. So a complex number might look something like this, okay? Might look something like this, might look something like that, okay? Just some combination of a real number and an imaginary number, or even just a real number is a complex number. 8's a complex number. It just doesn't have an imaginary with it. So, what can you do with these, right? Well, there's all these operations, so let's step through this. All the operations on complex numbers. So if I do this, so let's say we have 2 plus 5i, and I'm just going to put parentheses between just to separate them out, but you don't really need to. Okay? So adding these is really, really simple, and I bet if you just looked at it, you'd probably get the answer. Because you're just going to add the real parts and add the imaginary parts. That's it. And you can't combine a real and imaginary. Just like if I was just a variable, You can't combine a number and a variable. You know, learned that a long, long time ago. So that's it. Add the reals, add the imaginaries. Subtraction, same way. Add the reals. 3 minus 4, that's negative 1. Negative I minus a negative 5I. Negative I minus a negative 5I plus 4I. Okay, combine the reals, combine the imaginaries, done. Adding and subtracting is very simple. You'll be zipping through that like nothing. Okay. Multiplying. Now multiplying, not anything too rough either. There's just one little tiny thing to it. So if we're multiplying some complex numbers, again, I'm just going to pick an example because it's easier to show it to you that way. Alright? We're going to FOIL this. And again, I bet if I was to just say, hey, do these without even instructing, you would probably go ahead and FOIL them. Because that's just what your gut's going to tell you. Alright, so we got a 6, we got a 4i, we got a 15i, and we got a 10i squared. So almost every single time stuff here is going to come together, just like in a normal FOIL situation. And here's where the complicated thing comes in. So, I squared. Alright, so let's take a little side trip here for a second. I squared. Well, I is equal to the square root of negative 1. So I squared means you're going to take that and square it. So what's going to happen to the square and the square root in that case? They're going to cancel each other out. We're just left with negative 1. So whenever we have an I squared, we're just going to have a negative. So that means that this 10I squared is actually just going to be a negative 10. The I goes away because I squared is negative 1. So when you're doing the multiplication part, all you have to worry about is foiling, and then at that last term where you get two i's multiplied together, I times I is just going to make that number, and it's going to flip the switch. So if it's positive, it's going to be negative. If it's negative, it's going to be positive. So that's all that does. This is done. Yeah. So if we have like a negative 1 minus 3i, and we're going to times that by 2 plus 4i. All right. Again, we're foiling here. All right, and you should be really, really good at foiling. Obviously, you are. Okay. So minus 4i, minus 6i. So when I do this last one, and I go, well, let's see, that's going to be, right, a negative 12i squared. But what's it really going to be? So it's going to be a positive 12. Right? Because I squared is negative 1. And now I just finish it. There it is. It's done. So the only thing about multiplying is that I squared is negative 1. So it just flips that switch. If it's negative, it's positive. It's positive, it's negative. That's all we got to remember with that. So we added them, easy. Subtracted them is easy. Multiplication, not too bad. It's just foiling, right? The other thing we're going to do with them is do powers. Powers of I. And we've kind of already done it here. Okay, let's take a look at the first 4. So I is equal to the square root of negative 1. All right. I squared, we already figured out, was negative 1. I cubed. So I cubed would be equal to 1I times I squared, which is equal to, well, what did we say I squared was equal to? Negative 1, so that means this is a negative I. Okay, so we have I is equal to square root of negative 1. I squared is negative 1. I cubed is just negative I, because I squared is negative 1 times the I gives me I cubed, so that's negative I. I to the 4th. I to the 4th is going to be I cubed times the I. I cubed is negative I times another I. Oh my goodness. What are we going to get there? Let's see. So we're getting a negative I squared. So let's see. I squared is negative 1, right? So it's just 1. Okay? Interesting. But watch what happens. All right, now, let's do this. Let's do the next ones. You're probably thinking, is he really going to make us do this whole thing again? Well, watch what happens. So I to the 5th would be I to the 4th times an I. But we just said that I to the 4th was, what was that? What did we just say I to the 4th was?
1.
1. 1 times I is? Yeah. Now I to the 6th is going to be I to the 5th times the I. But heck, I to the 5th, we just found that. That's an I times the I is what? I squared, which is negative 1. So I think I'm starting to see a pattern here. I to the 7th. I to the 6th times I. Right? I to the 6th we just said was negative 1 times I. So what's that equal to? Negative 1 times I? Just negative I. So if we look at this, right, here's I, negative 1, negative I. I, negative 1, negative I. Any predictions as to what I to the 8th is going to be? There it is. So this thing is just going to continue to repeat, right? So if I said, hey, what's I to the 100th power? Well, you don't have to write all of them out. You can figure it out. Because what happens every 4th power on an I? Yeah, it repeats, it goes back to 1, right? So, look, this is going to be, since 100 is divisible by 4, nice and evenly, okay, then I know that this is just going to be 1. So I the 4th goes in there. Okay, it's going to be 1. I don't even have to know, I can just know how that works. I to the 59th. Ooh. 59 divided by 4. Right? 4 goes in there, let's see. 1, 2, with a remainder of 1, correct? We're good with that? Oh no, remainder, hold on. I didn't do that right. So anyway, let's try this again here. So, goes in there, it's going to go in there once here, so that's 4, so that's 19. 14, 16, with 3 left over, right?
Yeah.
Now I got it right. So 3 left over. Okay, so I go to my power of 3. My power of 3 says negative 1, or negative I. Well, that's negative I. Okay, so all I have to do is divide it by 4, okay? Because every 4th it repeats, and whatever the remainder is, that's what I'm going to have. Because all those other ones are just cycling through. So the only thing you're worried about is what the remainder is. Okay? That's the only thing we're worried about. The rest of them are just cycling through. So those are powers of I. All right? Again, it just goes I, -1, -I, 1, cycles through. All right? The last thing is division. The last operation we have is division. Let's take a look at that. All right. So, here is a division problem. All right. Very similar to the radicals, what we need to happen is we need to divide, or actually we need to multiply the bottom and the top by something so the i's go away, because the i's are radicals. Can't have radicals in the bottom, so we got to get rid of it. What we're going to do is multiply by 2 minus I and 2 minus I. And you say, why are we doing that? Well, what happens is, first of all, on the top we get this, right, which is no big deal. But on the bottom, when we FOIL this, look what happens to those middle things. What happens to them? They cancel out, right? -2 plus 2i goes away. All right, so the i's are eliminated. So by multiplying by this change here in sign, okay, that eliminates the I. So now we have 6 minus 3i on the top. That's okay. We can have all the i's we want up there. Down here we have a 4, and what happens to that right there? What does that become?
-1?
It's negative already,
Oh,
so it's just 1, right? So now 4 plus 1 gives us 5. There it is. So that's done. All right? This idea, okay, is called a conjugate. So if we have a plus bi, the conjugate is a minus bi. And vice versa. If we have a minus bi, the conjugate is called a plus bi. Okay? That's called the word conjugate. Now, I'm not going to ask you to give me conjugates. All right? I'm not interested in that. I'm just interested that you can apply them. All right? They're going to ask you in the book some problems on write the conjugates. All right? But if you're dividing, then you're going to know how to do it anyway. Okay? So that's what a conjugate is. All right? All we're doing is switching that sign, okay, between them. So let's try another one. So let's say we have 4 over 3 minus 2i. Right? We're going to divide these, so we're going to multiply the top and the bottom by that conjugate. So what would that be? Yeah, 3 plus 2i. Sure. Okay, so 3 plus 2i. All right, top is easy. We're just multiplying straight across there, no problem. Got it. Okay, 4 the bottom. There's 9. What happens when we do the 9 and the 2 and the 2 and the 3? What's going to happen to those? 3 and the 2i and the 2 and the 3. What's going to happen to those? They're going to cancel out. I don't even need to bother with it. And so I'm just going to go like this. Okay, I'm not going to do the middle ones because they're just going to cancel out anyway. It's just a waste of time. So I have a negative 4i squared, but really that's going to be a, what's that really going to be? Plus 4, right? Because again, I squared is negative 1, so it's flipping the switch. Positive to negative, negative to positive. There it is. It's done. Okay, so, I mean, you're thinking, I'm not even dividing anything. Yeah, you're right, you're not. all you're doing is rationalizing the exact same thing that we were doing last week, except we have complex numbers now. Nothing really changes. It's the same thing. All right? That's what's good about some of this stuff. You just keep repeating the same thing, even though it's a different problem. Like, that's why it's important to understand concepts in mathematics rather than rules and stuff. Okay. Oh, I didn't mention this. I probably should. If we want to rewrite this using a complex or using an imaginary number, okay, we would write this as square root of 8i, but I can break that down. Square root of 4 is 2, so I'm going to get 2i square root 2. Alright, so there's going to be some problems where you have this, okay? So you're just going to take the negative 1 and take the negative out. That's an I. That becomes here. And then you simplify the 8 like you did last week on your assignment. Right. So that's it. As far as I know, they use complex numbers in electricity, and there's a couple of other things I can't remember application-wise. Yeah.
I'm having trouble conceptualizing how great a negative is I times a negative. Is there a way you can work it out?
So what if we did this? Does that make sense so far?
Oh, right, because multiplying two rational numbers, you just multiply it.
Okay, so then this is the same as negative 1 times 8, right? Square root of negative 1, square root of 8. Square root of negative 1 times.
Okay.
Yep, good. Alright. But that's where complex numbers are used, because you might be asking, why would they even do this? I know they use them in electricity. I can't remember. There's another application too, like well. Right. Questions on complex imaginaries? Anything? Okay, so I'll give you some time to work on some stuff, but don't forget to pick up a review thing if you want one. All right, assignments go there. Don't forget that. And I'm going to pause it.